In the beginning, our main source of light was the sun. And when it set, we were in the dark. Until we discovered fire. Over time, we became more sophisticated in our ability to create and control light. In 1792, it was gas lighting. Arc lighting was used in Paris in 1841. The incandescent light was invented in 1854, and by 1879, Thomas Edison had worked out the bugs. Today, the humble light bulb has become an integral part of our lives. Imagine life without it. 20% of the world's total electricity is used to create light. And for the most part, we're relying on a light bulb that hasn't changed much in 100 years. The problem is that an incandescent light bulb is only about 5% efficient. That is to say, it turns out only 5% of the electricity into visible light. The rest is given off as heat. In other words, 95% of the energy is wasted. More than 60% of light bulbs on the planet are based on incandescent technology. And over 24% of the electricity used to power these billions of light bulbs comes from burning hydrocarbons. Fluorescent and compact fluorescent bulbs are 4 times more efficient than incandescent bulbs, but that's still only 20% efficient. Scientists knew there had to be a better way to build a light bulb, and here in Ottawa, they're building it. Group 4 Semiconductor is on the leading edge of an exciting wave of change.
Solid-state lighting uses semiconductor material to convert electricity directly into light. So that can be very efficient because there's just a conversion directly from electrons to photons.
Most solid-state lighting uses light-emitting diode technology, or LEDs. But to date, it's been very difficult to create an LED-based light that's bright enough and low enough in cost for anything but special-purpose applications.
We think that to get bright enough, to get the kind of color quality that's necessary, and most importantly, to get cost-effective, something that somebody will actually buy, is going to be very difficult for the mass market using LEDs.
The question is how to produce a solid-state lamp that is efficient, bright, and inexpensive. The solution? Silicon.
Silicon makes good sense because it's a widely used material. It's a readily available material. It's used throughout the semiconductor industry to make integrated circuits. All of the processing equipment already exists for it and is widely used and understood.
There's been discussion in the scientific literature or amongst people in university research labs about how to get light from silicon for some time, probably on the order of 10 years. What people have not been able to do very well, though, is control the properties of the silicon at the nanocrystal size until now. The Group 4 technology will be quite different from other solid-state lighting.
Here's how it works. A thin film of nanocrystals is embedded in a silicon chip. A current flows in through a conductive layer, allowing the electrons to reach the nanocrystals. Electrons impact the nanocrystals, energizing their electrons into an excited state. When the electron settles back into its natural state, energy is given off in the form of a photon. Millions of simultaneous collisions create light.
Group 4's product will be the light-emitting chip that goes inside a light bulb. And now our goal is to commercialize what we have, to take the fundamentals of the technology and the science and actually develop a product.
Great ideas are important. So are forward-thinking teams with experience who can help turn that great idea into a great commercial opportunity. Group 4 has been working with McMaster University and the Ontario Centres of Excellence to prepare the technology for deployment.
This is a lot of work and takes a long time, and so a large part of the work of the company has been to put in place the funding that'll allow that work to happen. We've been fortunate to attract 2 very supportive partners. One is Sustainable Development Technology Canada, and the other one is Encana through their Environmental Innovation Fund.
Now, Encana Corporation, through Encana's Environmental Innovation Fund, and Sustainable Development Technology Canada, are providing the support through the critical phase of development and demonstration to create the best possible chance of reaching the market and attracting further investment. Partners like these get involved because they see the long-term economic and environmental benefits to Canada.
The driver towards solid-state lighting comes from the recognition that if you can improve the efficiency of lighting, you can save a huge amount of the world's energy.
In this pre-commercial phase, Group 4 is embarking on a 3-year project, the Group 4 Encana SDTC Solid-State Lighting Project, to complete the development of the technology, demonstrate the technology in end-user applications, and literally create a brighter future. Imagine, if Canada adopted this technology, the energy saved would be almost twice the annual electricity consumption of all Toronto homes combined. Silicon-based solid-state lighting. Imagine a world with it.